Hi, my name is Dan Hansen, and I'm a Technical Marketing Manager with the Server Access and Virtualization Group within Cisco. This video is part of a series that is intended to show some of the unique advantages that is presented to Butte System for UCS. So within UCS, the fundamental idea is that there's many individual server devices that can be centrally managed and operated in a very simple and straightforward model. Part of this value implies the full management of firmware, of server state changes, of I/O reconfiguration, etc. Many of these policies and BIOS settings, etc., all need to be changed through the course, or perhaps could be changed through the course of a server's life cycle, especially when you start talking about a high degree of autonomy. The way we do this, fundamentally, manage this change, we start off with, in the servers tab here, we're showing some basic schedules. So there's a default with nothing. But I can create a normal maintenance policy here, and I can say that what we want to do is have a normal maintenance window. Again, with traditional offerings many times, the issue becomes as the quantity of devices to manage increases and the depth to which you need to manage this firmware can become quite a challenge. Okay, so the UCS centrally does this. So what we'll do is create a recurrence of a timer, Saturday, 2 a.m., and what we'll also do is put some metrics around the timer. So the max duration. How long do we want to keep this timer active and firing off? Another one could be number of tasks. How many times through should we limit this, if at all, in terms of firing off this timer? The next one becomes concurrent tasks. If we start off a task and it fires off multiple events, should we, depending on the length of that event, should another occurrence of this timer fire off or not? Or should we have a minimum time frame between these recurrences? All this allows for quite a bit of flexibility in terms of scheduling events within the UCS system. So now that we have our timer actually set up for a recurring timer, what we're going to do is we need to go and change some maintenance policies. Again, as this system could traverse hundreds of blades or rack mount servers, combination thereof within a system, we want to centrally control all of these devices. So in the default maintenance policy, you'll see there's quite a few devices out there, and that's just the immediate changes. That's legacy or the way things have always been done. What we can do with the UCS software now is actually say, let's put in a normal change definition. We'll make it a timer automatic and tie it into our maintenance schedule. By doing that, any queued up or pending changes that have occurred or been defined in the system will be just put on the shelf until the next maintenance timer window fires off. Now another one we can do is create a maintenance policy called queue the change. And what we do there is it'll wait for a user acknowledgement to actually enforce the change. So this is useful when you want to have a lower priority firmware management, RAID controller image, etc. that you just want to have queued on the system for whenever it's convenient you take down the server for some other reason. So now in the UCS we'll jump into the service profile, which is actually the server definitions themselves. Now on here you can see where I click on the maintenance policy, and I'll create one for one of these profiles, or associate a policy that says this is the normal change window for any pending changes on this server. And when I go into another profile, I'll show the other type that I have created. That one gets to be queuing up the changes for a manual association. So these are saved. One thing that's important to notice at this point, if the server is rebooted or we reboot it, nothing will happen. We want these timers or a manual association to change. So I'm going into the server right now, and I'm going to create a new firmware bundle, one that has a new storage controller, for example. And I'll make this change. Immediately when I do this, you'll see a pending activities. Indicator lights up and a balloon actually pops up on the screen. Let me know that there is pending activity to be done on the system. So when I look at the General tab, you'll see the pending activities callout is actually populated, and it says it's waiting for user. So on this one, nothing will happen on any timer event. It's waiting for a user acknowledgement to actually make the change. Now if I go to the other profile, do the same change, just that would require a reboot within the x86 infrastructure. BIOS upgrades, for example. We can do this, and again, the changes are pending. But in this case, it says waiting for maintenance window. Okay, it's all tied into the central maintenance window. So I have the two pending changes and the indicators within the system that lets me know that there's a change pending. Again, a reboot, or if a server were to reboot, do an OS or application event, this change would not happen. We don't want changes to affect any information or logging or debugging information. One of these discrete maintenance activities needs to happen in order for the change to take place. So here we have user acknowledged activities and scheduled activities based on the two types that we've created. And here's where we'd select the button and force the change immediately if we chose. On either type of activity, we can force a change now. When I look at my normal change, I can look at the policy usage, I can look at my regular queued up changes, look at the policy usage to have an immediate view over what is being used by whom. Now if I go back into these server profiles and say, oops, I actually didn't want to do the change, I'm backing out of the change that I had assigned to these two blades, what you'll see actually is as I restore the original images that were there, that the pending changes indicators have now been grayed out. And as I look at the General tabs, no longer are there pending changes waiting for user acknowledgement or waiting for the timer event to actually occur. So this is showing basically the ability to control and modify change behavior to be much closer tied into the system. Again, with UCS and managing a large quantity in a highly automated fashion, the real goal is to get away from perhaps a legacy idea of individually managing chassis or blades and controlling change windows, and do it more centrally. For more information, you can go to cisco.com/GoUCS, and thanks for your time.